Yeah, good evening everyone. Good evening. Dheeraj, I am fine. I hope you too. Ignoring every time. Arey, some buffering is going on, man. Where I am ignoring? Arey, Dheeraj, I am coming to YouTube for ignoring or what? How can you talk like this, Dheeraj? Just buffering is going on. That's the reason I am thinking. Every LL1 grammar is CLR1, right? Not LR0, right? Every LL1 is CLR1. Buffering. Is it okay now? I think now it's fine. Please check. I think now it's fine. Is it okay now? Is it okay? Thank you, Dheeraj. Thank you so much. Thank you so much. Thanks everyone for participating. Right? Yeah, this particular, right, this YouTube streaming is killing me. That is the reason I asked you to join Unacademy. You are not listening. You are not listening. See, this YouTube is killing me. It is killing my life. I keep on saying join Unacademy, join Unacademy. You don't listen. You don't know Unacademy app. Unacademy app is so nice. So nice. No streaming problem, nothing. It's far better than YouTube. It is far better than YouTube. You people don't listen. Arey, Dheeraj, you don't listen. Right. Let me start now. Let me start. Yeah, I'm starting series 1. So yesterday we done the big O, omega, theta, right? Some problems we done. So please go through them. Now next one, right? Recursion. Let's go to recursion. Yeah, now let me start now recursion. So everyone know recursion definition. A function calling itself. A function calling itself. A function calling itself is known as recursion. Is known as recursion. A function calling itself is known as recursion. It is a function definition. It is the recursion definition. A function calling itself is known as recursion. This is the recursion definition. Everyone know this. Everyone know. So let me explain now. Right, fine. Array, there is control, man. This is the YouTube. This is the YouTube control. How can I say that kind of thing? You are talking so unprofessional way. How can I talk in the YouTube like this? Please say buffalo like this. So how can you talk like this? Listen properly. A function calling itself is known as recursion. So I given the definition. Can you see the example? One example for this. One example for this. One example. Let us assume that I want to find out. Let us assume that I want to find out a factorial of 4 or factorial of 6. I want to find out. I want to find out factorial of 6. Factorial of 6 is equal to, right? Everyone know. Factorial of 6 is equal to 6 into factorial of 5. Factorial of 6 is equal to 6 into factorial of 5. So if you observe clearly, right? Fact is calling fact. Check. If you observe clearly, to find out one fact, you are calling another fact. Fact calling fact is known as recursion. Right? I may write within few minutes, I may write the program also, that's okay. But this is the meaning of recursion. A function calling itself is known as recursion. A function calling itself is known as recursion. See this one. So some students are asking, sir, where is the recursion, sir? Here. Fact calling fact, recursion. Fact calling fact, right? Recursion. Right, now see the next one. So what about fact of 5? What about fact of 5? If you know fact of 5, you can stop here. If you don't know, same story. 5 into fact of 4. Again, fact calling fact. Again, fact calling fact. At any point of time, if you know, you can go back. If you don't know, you can come down. If you don't know, go down. If you don't know, go down. If you don't know, go down. If you know, come back. If you know, come back. Next one. If you know the answer, go back. If you don't know, come down. Some people are asking, what about fact 4? 4 into fact 3. Some people are asking, what about fact 3? Right? 3 into fact 2. If you know, you go back. At anywhere, if you know, go back. What is fact 2? 2 into fact 1. At anywhere, right? At anywhere, if you know, you can go back. If not, go down. Right? I think everyone know fact 1 is 1. Everyone know fact 1 is 1. Right? Everyone know fact 1 is 1. Can you help you know? Fact 1 is 1, everyone know. 2 into 1 is 2. So you can go back. It is 2. 3 into 2, 6. Right? It will 6. 4 into 6, 24. This will be 24. This will be 24. 5 into 24. This will be 120. 120 into 6, 720. So like this, 720. If you know at anywhere, go back. If you don't know, go down. A function, so some people are asking, sir, where is the recursion, sir? If you want, you can observe. Fact calling fact many times. Fact calling fact many times. Fact 6 calling fact 5. Fact 5 calling fact 4. So recursion is nothing but a function calling itself is known as recursion. A function calling itself is known as recursion. So I done this. Those people who are having small doubt also, sir, this is my doubt, you ask me, I will help you. A function calling itself is known as recursion. I written on the board also, I given one example. Yeah, Deras, thank you so much. Deras, thank you so much. Yeah, those people who are watching, if you have doubt, let me know. Recursion, do you have any doubt? Recursion, do you have any doubt? If no doubts, I can go further. If no doubts, I can go further. If no doubt, I can go further. Now let's go to next. I think I written the recursion definition. Right, followed by one example I given. Check. Small doubt also verify. I hope no doubt. Now see the next one. I think if you observe clearly, calling, it's okay. Some point of time you have to go back. Calling, it's okay. Some point of time you have to go back. If at all, if it means this is the place where you have to go back. Some point of time you have to go back. If you don't go back, then when the program will be over, some point of time you have to go back. So this is called, some people are asking, sir, at which place I will go back? That point is called as termination condition. Whenever you say recursion, you are calling. So if you keep on call, when you go back, if you don't go back, when will you see output? So some point of time you have to go back. Some point of time you have to go back. The place where you go back, that is called termination condition. Remember, every recursion should have termination condition. So I think I given the definition for recursion. That is the first point. Right? Definition for recursion. I give in the first point, see the second point. Every recursion should have termination condition. Recursion should have termination condition. Recursion should have. Recursion should have termination condition. Recursion should have termination condition. Right? Some people are saying, sir, you are keep on calling, it's okay. Where will you come back? That point is known as termination condition. Some people are asking, why you come back? If you don't come back, when you see output, okay, you are not coming back, you are keep on calling. Then when you see output, so when you are going, you have to come also. The place where coming is started. The place where coming is started. That is known as the termination condition. Every recursion should have termination condition. Every recursion. When you say recursion, calling means you are going down. You have to come back some point of time. You have to start coming. At which place you start coming, right? That is known as termination condition. Right? Recursive program should have termination condition. That is the second point. Recursion should have termination condition. Right? Fine. Fine. Now see the next one. Third point. See the third point. 3. So if you observe clearly, fact 6 is solved in terms of fact 5, fact 4, fact 3, fact 2, fact 1, and so on. Again I am asking you, right? Fact 6 is solved in terms of fact 5, fact 4, fact 3. So recursion is nothing but solving bigger problem in terms of small problems. Recursion is nothing but solving big problem in terms of small problems. Solving big problem solving big problem in terms of small problems. Recursion is nothing but solving big problem in terms of small problem. This is the next point. Recursion is nothing but solving big problem in terms of small problem. In terms of small problems. This is the third point. See, recursion definition I given one example also. But by doing that example, you got to know you are going. Some point of time you have to go, you have to come back. The point where you started coming back, that point is called termination condition. Some people are asking, oh, sir, why should I come back, sir? If you don't come back, how you get output? You are keep on calling, you are not coming back, then how will you get output? So you have to go some point of time, you have to come back. The place where coming back is started, that point is called termination condition. So recursion should have termination condition. Next one. So by seeing this problem, I can say fact 6 is solved in terms of fact 5. Fact 5 solved in terms of fact 4. Fact 4 solved in terms of fact 3, right? And so on. So by seeing this problem, I can say recursion is nothing but solving big problem in terms of small problems. Solving big problem in terms of small problems. 3 also over. Let's go to 4. 3 also over. Let's go to 4. Is there anyone who is having doubt? Solving solving big problem in terms of small problems. Anyone having doubt? See, if you don't respond, it's very difficult to explain. This is the problem with the YouTube. People don't respond. This is the This is the, see, in the plus class, great interaction, great. I will ask one question, immediately they will give answer. Right? They will ask one question, immediately I will give answer. So there is a nice cooperation. In the plus class, there is a nice cooperation. In the YouTube, the problem is sometimes buffering is going on. Sometimes you don't listen. Sometimes you don't listen. Sometimes is buffering problem. Some delay also there. That's the reason it is not exciting. It is not exciting. My suggestion is please respond. Please respond. My suggestion is please respond. Now, see the fourth point. See the fourth point. Everyone listen. Everyone listen this. See the fourth point. See the fourth point once. Everyone have to listen. Fourth point. See the fourth point. See, first one. Careful everyone now. First fact 6 is called. First fact 6 called. Remember fact 6. So n value 6. First fact 6 called. So n value 6. First fact 6 called where n value 6. Then if you see the logic inside, then what is the answer? N into fact of n minus 1. N into fact of n minus 1. First fact 6 called, fact 6 is equal to n into fact of n minus 1. Right? Next one. So can you help me now? If n value 6, 6 minus 1 is 5. So because of it, it is a function call again. Right? Because of it, the function call again. Again, see this one. Again, fact of n called. Where n value here is 5. Again, same code. N into fact of n minus 1. That is the meaning of recursion, right? Executing the same code again. Again f of n. Where n value is 4. Right? N into fact of n minus 1. What is the meaning of recursion? Executing same code. Again f of n. Where n value 3. So n into f of n minus 1. Some people are asking, sir, same code, sir. That is the meaning of recursion. Of course, same. 2. So again, n into f of n minus 1. Next one, f of n minus 1 again called. Again f of n, where n is 1. So now see this one. I think everyone knows this is the termination. Now see, from termination onwards, some different story will happen. What is the answer? See the different story. N value 1. See, this is the 1. N value 1. Fact 1 is 1. Then automatically see this one. N value 1. So you have to return. Termination condition onwards, you have to return. This value becomes 1. Can you help me now? What is the n value in this box? 2. What is the n value in this box? 2. So 2 into 1 is 2. So returning value 2 will goes to here. Next one. What is the n value in this box? 3. 3 into 2 is 6. 6 will goes to here. It is the 6. What is the n value here? 4. 4 into 6, 24. 24 will goes to here. It is the 24. Right? N value here 5. 5 into 24 is 120. 120 here. Next one. I think n value 6. 6 into 120 is going to be, right? 6 into 120 is going to be 720. 720. Yeah. If you observe clearly, listen. If you observe clearly this diagram, if anyone says, sir, it is not visible. If anyone says, sir, this is not visible, just I want to say one thing to you. Listen. In every slot, same code is there. N into f of n minus 1, n into f of n minus 1, n into f of n minus 1. That's the meaning of recursion. Every time you are executing same code. And one more, see this one. Every time you are calling f only. Every time you are calling n only. See this one. Inside n only. Every time n only. See this one. Function name same. Function name is same. Next one, parameter name also same. Number of parameters also same. Whenever recursion is going on, same function will be called. Next one, when you say same function, same parameter names.
Same parameter names, same number of parameter also. See, one parameter here, f of n, one parameter n, f of n, one parameter n, f of n, one parameter n, and one more, same code also. When you say recursion, same function name called. Next one, same parameter passed, same number of parameters are passed, same code also executed. Same code also executed. Now some students are asking, sir, if at all everything same, then one function call to another function call, what will be the difference, sir? If at all everything same, one function call to another function call, what is the difference, sir? The difference is value. One function call to another function call, the difference is value, n value changing. The difference is value. Whenever recursion is going on, one function call to another function call, code will be same. Function name will be same. Number of parameters are same. Name of the parameter also same. The only thing is one function call to another function call, value will change. Value will change. Some students are asking, sir, how can you write the same thing in every box? That is the meaning of recursion. That is the meaning of recursion. And one more. From which point onwards coming back is going on? From which point? I think this point onwards. This is called termination condition. From which point onwards you are going back? That is called termination condition. So see this one. All the black color things, if you see, they are coming down. Black color things are coming down. Black color things are coming down. All black color things are coming down. All black color things are coming down. Next one. Red color things are going up. Calling means going up. Calling means going up. Returning means coming down. When you call a function, you will go up. When you return a value, you will go down. Can anyone help me now? In the stack terminology, what is the meaning of going up? Push operation. In the stack terminology, what is the meaning of going down? Pop operation. So remember, function call is a push operation. Function returning is a pop operation. So when you say recursion, function calling means push. When you say recursion, function is calling 20 times, then 20 push operation. When you say function is over, means you are returning, means pop operation. Function over, return, pop. Function over, return means pop. So function call is a push operation. Function over means return is a pop operation. Remember how many push you do, those many pop you have to do. 20 push you done, compulsory 20 pop should be done. Next one, in every slot if you see same code, same names, same code, same function name, same parameter name, same parameter, same number of parameter. The only change is value. The only change is value. I think some students are asking, sir, why are you talking about push and pop? Remember, not one function call here, not two function call, many function call. Because of many, you have to use some data structure. The data structure you are using is stack. To execute a program inside the computer, we are using stack data structure. Need not be recursion. Non-recursion also stack required. Function call is a push operation. Function over is a pop operation. It is a recursion, non-recursion, doesn't matter. When you say non-recursion, in every slot different code is there. When you say recursion, in every slot same code is there. Recursion means same code, non-recursion means different code. But one thing, you have to use stack. Function is, let's see this one, a program is running. Stack automatically will come. When stop, function call, push operation. Function over, pop operation. So, I think by this example, listen, fourth point I want to say to you. Whenever recursive program is running, means we are using stack data structure. Recursive program running means you are using stack data structure. Non-recursion also stack.
Yeah, any doubt? Those people who are watching, any doubt? Check one time. 4 points I covered till now. 4 points I covered till now. Till now I covered 4 points. Till now I covered 4 points. If you okay with these 4 points, can you see the next one? If you are okay with these 4 points, can you see the next one? 4 is over. Let's see the 5. Let's see the 5. To execute recursive program, we are using stack. To execute recursive program, we are using stack. To execute recursive program, we are using stack. That is the 5th point. Go to the 6th point. To execute the recursive program, we are using stack. Next one. While recursive program running from one function call to another function call, 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 while recursive program running from one function call to another function call, right? See this one. While recursive program running from one function call to another function call, see this one. Another function call, function name will not change. While recursive program running from one function call to another function call, function name will not change. Next one. Number of parameters will not change. Number of parameters will not change. Next one. Name of the parameter will not change. From one function call to another function call, while recursive program running from one function call to another function call, function name will not change. Number of parameter will not change. Name of the parameter will not change. But what will change? Let me write this one. What will change is parameter value will change. Parameter value will change. It is the 6th point. While recursive program running from one function call to another function call, function name will not change. Number of parameter will not change. Name of the parameter will not change. Parameter value will change. Can you see the first point? A function calling itself is known as recursion. So I give an example. Fact 6 calling. Fact 6 is nothing but 6 into fact 5. Fact 5 is nothing but 5 into fact 4. Fact 4 is nothing but 4 into fact 3. Fact 3 is nothing but 3 into fact 2. Fact 2 is nothing but 2 into fact 1. Fact 1 we know. So 2 into 1 becomes 2. You have to go back. So 2 will go back. 3 into 2, 6. 6 will go back. 4 into 6, 24. 24 will go back. 5 into 24, 120 will go back. 120 into 6, 720 will go back, like that. Right. So what I want to say is, when you say recursion, you are going down, you are calling. Means you are going down. But some point of time you have to come back. So you are coming back. The place where you are coming back, that is called termination condition. This is the starting point where you are coming back. So, right, recursion, every recursive program should have termination condition. If termination condition is not there, you are going down. You are not coming back. You will never see the output.
recursion should have termination condition. Termination condition is not, right, not the place, right, you are coming back. The place, the first place where you are coming back. See, many places you are coming back. How many times you are going down, those many times you are coming back. The place, first time you are coming back, that is called termination condition. Every recursion should have termination condition. 3. Recursion is nothing but solving big problem in terms of small problems. Recursion is nothing but solving big problem in terms of small. Some people are saying, sir, how, sir? If you want, you can see this example. 6 is solved. Let me use another color. You will get the idea. Yeah, I am using the green color. See this. See this one. To solve the 6, I am calling 5. To solve 5, I am using 4. To solve 4, I am using 3. To solve 3, I am using 2. To solve 2, I am using 1. That means bigger problem is solved in terms of smaller problems. 6 is solved in terms of 5. 4, 3, 2, 1. So, recursion is nothing but solving bigger problem in terms of smaller problems. Okay, fine. And one more. When you say recursion, so many functions you are calling. When you say recursion, so many functions you are calling. These, right, those many functions you are calling, where they are staying. They have to store somewhere. When you call many, they have to store somewhere. Suppose assume that your family members, 10 family members, one family member can stay somewhere, that's fine. But many family members, where they will store? They will store in the house. Whenever number of people are more, some house needed. If only one person, on the road you can dance. Suppose in a family only one person, he can dance on the main road. He can dance on the national highway. He can sleep in the metro. He can sleep in the railway station, bus station. But many people are their family. Family contain 10 people. Compulsory one data structure required to store. When you say recursion, many function calls are there. When you say recursion, many function calls. Where they all will store? Compulsory some data structure needed. The data structure what we are using is stack. The data structure what we are using is stack. All will store in the stack. Recursion means, right, we are using stack data structure. Right? Some people are asking, stack means so many units are there. Sir, in every unit what is there? Same code. Because of recursion, same function in same code. If it is a non-recursion, then also stack only. But in every slot, different code will be there. In the case of the recursion, same code is there because same function call. Same code because of same function call. Non-recursion, different code because of different function call. But one thing, recursive program running, inside you are using stack. Non-recursive program running, inside you are using stack. In the non-recursion, in every slot, different code will be there because of different function call. In the recursion, in every slot, same code is there because of same function call. But one thing, to execute recursive program, we are using stack data structure. To execute non-recursive program also, we are using stack data structure. Right? Because of recursion, I written only recursion. Can you see the fourth statement? Third one is completed. See the fourth statement. To execute recursive program, we are using stack. Some people are asking, sir, first of all, why data structure needed? Are these many functions, if at all data structure not there, where they will store? 10 members in the family, if house not there, where they will store? Where they will stay? Same way, recursion many function call, right? That definitely there is a need of some data structure. I think the fifth point also okay. See the sixth point. While recursive program running from one function call to another function call, function name will not change. See, recursion is running. See this one? F called F 6 times. Every time same F only. See. Whenever recursion going on, you will call the same function many times. So function name will not change. Some people feel that function name will not change, so code will change. How man? How code will change? Function name not changes, how code change? Some students are saying recursion going on, same function call you will call. But code will change, na? How code will change? Because of recursion, same code, because of same function. So when recursion going on, function name will not change, code also will not change. Next one, name of the parameter cannot change, number of parameter cannot change, only parameter value will change. Parameter value will change. See this. While recursive program is running from one function call to another function call, function name will not change, number of parameter will not change, name of the parameter will not change, but parameter value will change. Check if anyone having doubt. So that will be the, what is the point number? Point number 6. Point number 6. Okay, fine. Until now it's okay. Can you go to the seventh point? Seventh point. Seventh point. Every recursive program should have termination condition. As you know, every recursive program should have termination condition. Every recursive program should have termination condition. Otherwise what will happen? Can anyone guess? Every recursive program should have termination condition. Otherwise what will happen? Can anyone guess? Every recursive program should have termination condition. Otherwise what can happen? Can anyone guess? Otherwise what can happen? Can anyone guess? Every recursive program should have termination condition. Otherwise what will happen? If anyone knows. Can anyone guess? Every recursive program should have termination condition. Otherwise what can happen? Termination condition. Otherwise what can happen? I want answer. Check. Those people who are watching, please respond. Every recursive program should have termination condition. Otherwise what can happen? I want answer from you. I am looking for a better answer. I am looking for a better answer. Can you check? Every recursive program should have termination condition. Otherwise what can happen? Can anyone guess? Anyone can give answer. Every recursive program should have termination condition. Otherwise what can happen? Can you help me? Otherwise what can happen?
It is a nice point. It is a nice point. If I say directly, you don't remember. If I say directly, you don't remember. That is the reason I took some time. Please, anyone can give answer. Every recursive program should have termination condition. Otherwise, what can happen? Otherwise, what can happen? Can anyone give answer? Otherwise, what can happen? Otherwise, what can happen is, listen. Otherwise, what can happen is you only say function call push, function call push, function call push. Then what is the answer? Because of lack of termination condition, you will keep on pushing. First two, right? Let us enter first F6 push. Next F5 will push. Next F4, next F3, F2, F1, F0, F minus 1, F minus 2, F minus 3. You will keep on pushing. But everyone know, right? Number of resources inside the computer is finite. So stack size is finite. If you keep on pushing like this, at some point of time, stack size is over. When you are keep on pushing inside stack because of you are not coming back, you are keep on pushing, right? It will push like that, right? Until stack is over. So what I want to say is, if a recursive program don't have termination condition, then what will happen is, right? You will get the error message stack overflow. You don't go to infinite loop. You will get error message stack overflow because some point of time stack is over. You will get error message stack overflow. You will get error message stack overflow. Siddharth, hi. Otherwise we will get stack overflow, error message. Otherwise we will get stack overflow, error message. Every recursive program should have termination condition. Otherwise, we will get stack overflow, error message. Can anyone help me now? Will it go to infinite loop? Will it go to infinite loop? Will it go to infinite loop? Can anyone guess? Every recursive program should have termination condition. Otherwise, will it go to infinite loop? No, it don't go to infinite loop. It don't go to infinite loop. It want to go, but unfortunately, right? Every function call is a push operation. When you are keep on pushing, stack size is over. Because you are not stopping, you are keep on pushing, stack size is over. Then what it will do is, because of stack size over, it will stop some point of time because of stack space over. It will produce one error message, stack overflow. Some people are thinking that stack overflow is a website name. Some people are thinking that SAR is promoting Stack Overflow website. Some students are thinking that I am promoting Stack Overflow website. No, it is not Stack Overflow website. It is a Stack Overflow error message. Anjali, it is not. It is not Stack Overflow website. It is a Stack Overflow error message. Siddharth, try to understand. It is not a website name. It is the error message Stack Overflow. It is the error message Stack Overflow. It want to go to infinite loop because of space not there. Then the middle of the program it will stop. It will give error message Stack Overflow. So this is the 7th point. Every recursive program should have termination condition. Otherwise, we will get to Stack Overflow error message. That is the 7th point. See the 8th point. To execute recursive program, the number of stack units. To execute recursive program, the number of stack units we used. The number of stack units. The number of stack units. The number of stack units we used.
is known as depth of the stack. Depth of the stack. To execute recursive program, the number of stack units we used is known as depth of the stack. Can you help me now? For our problem, right, n value 6. For our problem, n value 6. How many stack units you used? How many? 1, 2, 3, 4, 5, 6. To execute this recursive program where n value 6, I used 6 stack units. So depth of the stack is 6. To execute this recursive program, how many stack units you are using? That is known as depth of the stack. That is known as depth of the stack. I think 8th point also clear. Right? 8th point also clear. It's totally 8 points I covered till now. Please, right? Please, those people who are watching, can you write down in the comments? Can you write down in the comments 1 by 1 point? 8 points I said. Without seeing the class, right? Can you, if you remember, can you write 1 by 1 point? What are the things you understood? What is the first point? What is the second point? What is the third point? 8 points I said. Without seeing the class, can you write 1 by 1? Roughly you write. There is no requirement of writing as it is. You can type roughly. What is the first point? What is the second point? What is the third point? I am giving 1 or 2 minutes time. Can you type roughly? What is the first point? What is the second point? Totally 8 points are there. They all are valuable statements. Can you type once? Can you type once? I am hiding also. Can you type once? Right. I hope everyone is fine. These 8 points you all people got. These 8 points all people got. Right. Before proceeding further, let me check once. Before proceeding further, let me check once. Almost everyone is written 1.
Recursive program is function calling itself. 2 should have termination condition. 3 solving big problem using small problem. 4 stack data structure while using. 5 only, right, function value changes, right. 6 if no termination condition, stack overflow happens. Number of stack units we are using, that is called depth of the stack. Thank you so much, Anjali. Thank you. Thank you. It's a nice contribution, right? Nice cooperation. Thank you so much. Thank you so much. Let me say something about Unacademy. Let me say something about Unacademy. There is a 30% offer is going on. There is a 30% offer is going on. Use referral code ReddySir. There is a 30% offer is going on. Use referral code ReddySir. And one more. See this one. If you are preparing for 2024 GATE exam or 2025 GATE exam, or you are a second year student or third year student or fourth year student, or right, you are doing job, or you are preparing for job, or you are preparing for competitive exams, you are preparing for software companies. My suggestion 2024 GATE exam you want to write, or 25, or second year student, third year student, fourth year student, and you are preparing for job, or you are doing job, you want to go for higher education, you are preparing for competitive exam. So my suggestion to you is, if you want to prepare, if you want to go for higher studies, if you want to get right high package jobs, my suggestion, get the good GATE rank. You will get the high package jobs. Get good GATE rank. You will get the high package job. CSE people anyhow will get job. CSE people anyhow will get job. But when you study from the premier institute, when you get the nice rank, right, you will get the higher package job. You will get the PSU job easily. You will get the big companies, right? My suggestion is, please start preparing today. Please start preparing from today. And one more suggestion is, right, start preparation today. Start preparation today. One more suggestion is, join Unacademy today. Join Unacademy today, because there is a lot of advantage. In the YouTube studying, very difficult, you know, lot of frustration will be there. In the YouTube, so many videos are there. Below one video, above one video, it will confuse you a lot. It will waste lot of your time also. Until unless really problem, my suggestion is, don't go for YouTube videos. My suggestion is, please join the plus course or iconic course. Join if you are really serious. I can understand, right? I can understand maybe money problem. I can understand. So they given 30% off also. Studying in the YouTube really difficult. Until unless, right? Until unless you are so determined. In the YouTube it is very difficult. Sometimes it will test your patience. Sometimes it will test your patience. Right? Lot of buffering is there. Lot of lagging is there. Right? And one more thing, by seeing the number of people who are participating, how they are participating, right? So I think concentration may decrease to you, concentration may decrease to me also. So my suggestion, if you are really serious, my suggestion is, join Unacademy today only. Don't waste little bit of your time also. Don't waste. Next one. There is a all India level. There is a test is going on. All India level practice test. Right? 4th December is there. 18th December, 8th January, 15th January, 22 January, 29 January. Use referral code ReddySir, right, to write those tests freely. Next one. There is a EMI option also there. You can join EMI option also. Within 2 hours they will approve. Minimal paperwork, flexible tenures. Next one. Notes also available. And one more good news to everyone, whoever watching, there is a good news to you. Morning 6 o'clock, morning 6 a.m., algorithm is going on in plus course. Trust me, on YouTube, whatever I am teaching, only few topics I am teaching. Because I cannot teach all the topics. Only few topics I am teaching. Actually, Algo DS I have to teach approximately 100 lectures. On YouTube I am teaching only 25-30 lectures.
I cannot teach all, it is not possible also. My suggestion to all of you is, right, if you want to complete, right, I'll go DS as soon as possible, every topic, right, morning 6 a.m. algorithm is going on. 6 to 9, morning 6 to 9, algo is going on. First I will teach algo, followed by data structure, followed by TOC, followed by compiler design. Next one, computer network, discrete mathematics. Next one, digital, right? These are the things. Right? Remaining subjects, some more good teachers are there, they will take care. My suggestion is Unacademy faculty will guide you like anything. Suggestion is, if you are really serious, join as soon as possible. Don't waste your time. Don't think that, right, by studying YouTube you will get the very good rank and all. Other than time waste is nothing there, in my opinion. I'm really sorry to say this. I know that you have some financial problem. I know this. That is the reason there is a that 30% off going on. Use referral code ReddySir. Next one, those people who are preparing for 2023, right? So you can take the 4-month subscription. You can write the test series, right? 60 plus tests are available. 60 plus tests are available. Right. Next one, series 1. 2024. If you are preparing for a 2024 GATE exam, or second year or third year, fourth year student, job going, whatever it is, if you want to improve in your life, if you want to improve in your life, if you want to go for higher education or a high package job, trust me, Unacademy really helpful to you. Go for iconic subscription, 1.5 years. Iconic subscription, you go. Learn as much as possible. Gain as much knowledge as possible so that you can mold your life in the better way. The advantage with the iconic top educators are the digital notes, test series, customized doubt solving, printed notes, live mentorship, strategy and study planner, right? Interactive open sessions. Many advantages. Right. Let's come back. I said the recursion. Right. Let's go to next one. Now, listen everyone. Now, factorial program, let me write. Factorial of n, series 1. If n is equal to 1, return 1. N is equal to 1, return 1. Else return n into fact of n minus 1. Else return n into fact of n minus 1. So remember everyone, it is a factorial recursive program. This is the way of writing. Factorial recursive program. This is the way of writing. It is a factorial recursive program. This is the way of writing. Fact of n. If n is equal to 1, return 1. Else return n into fact of n minus 1. Remember, recursive programs are very easy to write. Recursive programs are very easy to write. But the reason is if condition, else condition. Recursive programs are very easy to write. If condition, else condition. If condition, termination. Else condition, major code. And one more important thing is, code is very less because in the recursion you are using the same code again and again. That is the reason code is very small. Because same code you are using many times. Recursive program running may be taking more time, but writing is easy. Recursive program running will take more time because you are executing same code many number of times, but writing so easy. If condition, else condition. If termination, else running. So else part, if you see again and again, else part running. So if condition will execute once only. Termination will execute once only. Remaining all the time, else part will execute. So this is the way of writing a recursive program. Some people are asking to do factorial. Sir, to do the factorial, you written the recursive program, we are very happy. Can you write the non-recursive program? Right? Can you write the non-recursive program? Let me write now. Recursive program purpose, right? Factorial purpose, recursive program you written, it's fine. But what about non-recursive program? See the non-recursive program? Fact of n. See the non-recursive program. Fact of n. Take one for loop. I is equal to 1. I less than or equal to n. I plus plus. Take one for loop. The inside s is equal to s into I. S is equal to s into I. Lastly, return s. Lastly, return s. End of the function. Now, initially s is 1. If you want, you can verify. One for loop. Write one for loop. If anyone says, sir, it is not visible, I will write again. If anyone say it is not visible, I will write again. Let me write again. If anyone say, write once again, sir, I will write. See, it is a non-recursive program. Non-recursive program. Factorial non-recursion. See this one? Fact of n. If n is equal to 1, return 1. Else return n into fact of n minus 1. Oh, sorry for this. Right, non-recursion, right? So let me write the non-recursion. Right, so I'm writing the non-recursion, very easy. 1 times c. S is equal to 1. For I is equal to 1, I less than or equal to n, I plus plus. I is equal to 1, I less than or equal to n, I plus plus. Next one, inside s is equal to s into I. S is equal to s into I. Lastly, return s. End of the factorial. So see this program. If anyone is not able to see one time. Fact of n, s is equal to 1. Inside, this loop is repeating. If I give n value 6, this loop repeating 6 times. N value 6, if I give, this loop is repeating 6 times. Right? This loop is repeating 6 times. So initially I value 1, s is 1. 1 into 1 will store in s. Second time 1 into 2 will store in s. Third time 2 into 3 6 will store in s. Fourth time 6 into 4 24 will store in s. Next time 24 into 5 120 will store in s. Next time 120 into 6 720 will store in s. Next time I value becomes 7, condition fail. Out of the for loop, return s. 720 will be returned. 720 will be returned. So this is the non-recursive program. This is the recursion. Why it is recursion? Fact calling fact. It is a recursion. Inside fact there. But here if you observe, in the second program if you observe, inside fact nowhere fact is there. Inside fact nowhere fact there. So it is a non-recursive program. It is a recursive program. Remember everyone. For every recursion, non-recursion possible. Right? 8 points are over. See the ninth point. See the ninth point. For every recursive program, equivalent non-recursive program possible. For every recursive program, equivalent non-recursive program possible. You cannot say recursive program there, non-recursion not there. You cannot say non-recursion there, recursion not there. You cannot say. For every problem, recursion there, non-recursion also there. For every problem, recursion also there, non-recursion also there. I am repeating once again. For every problem, recursion also there, non-recursion also there. Recursion is meant for user comfortability. I think if you observe clearly, writing recursion, non-recursion, recursion writing easy. Writing recursion and non-recursion, recursion writing easy. Non-recursion writing is difficult, but it's a good for computer. Computer like non-recursion. User like recursion. User like easy things. User like easy things. You know very well, easy things are not good for health. When you write easy program, computer may not like. But when you write, when easy thing is there, user like. Recursive program, user like, computer don't like. Non-recursive programs, computer like, user may not like it. So you cannot get all plus minus, all the things at a time. Some positive is there, some negative. Recursion, good for programmer, may not good for computer. Non-recursion, good for a computer, may not good for the programmer. Right? Depending upon requirement, we have to select. But one thing, for every recursion, non-recursion there. For every non-recursion, recursion there. So anyone having any problem, please let me know. Sir, I have this doubt. 9 points I said. 9 points I said. And one more thing I want to ask you. Recursion, non-recursion, which will take more stack space? See this one? Because of here one function called C. Fact n is called. In the non-recursion, if you observe, fact n is called, but you don't call any person inside. Here one function call, one stack unit. Non-recursive program also will take stack. But I think negligible stack, almost like 1 unit of stack. Non-recursion will take stack, almost constant. Negligible. But recursion will take fact of 6 units. Fact of 10 units. Fact of 20 units. Fact of 1 lakh units. But non-recursion, only 1 unit. So remember, recursion and non-recursion. Recursion and non-recursion. Recursive program and non-recursive program. Recursive program, non-recursive program, if you consider. Recursion, most of the time will take more stack space. Recursive program and non-recursive program, if you compare, recursive program most of the time will take more stack space comparing non-recursion. Comparing non-recursive program. Comparing non-recursive program and recursive program, most of the time recursive program will take more stack space comparing with the non-recursive program. Sometimes maybe both same. I cannot say every time. Most of the time, recursion will take more stack space comparing with the non-recursion, because recursion having more function calls. Non-recursion having less function call. Non-recursion having less function call. Recursion having more function call. More function call, more stack. Less function call, less stacks. Sorry, more function call, more stack units. Less function call, less stack units. So most of the time recursion will take more stack space comparing with the non-recursion. Non-recursion also will take, but it will take less. But recursion will take more, most of the time. So this is the 10th point. See, today entire class I explained to you. What is recursion. Major points I said. It will be really useful to you. If you are little bit lucky also, in one of the technical interview, people will ask you, can you explain recursion? You explain all these points, they will give job to you. If you are little bit lucky also, in one of the interview of your lifetime, right? Of course, you will start going to the interviews. Some point of time they will ask you, can you explain recursion? Just explain all these 10 points. Definitely they will impress, they will give job also. Any doubt check? Those people who are watching, my suggestion is early morning algo is going on. Followed by DS, followed by TOC, followed by compiler design, followed by computer network, discrete mathematics, digital, All subjects are going to be happened one by one. Morning one, evening one. Morning is algo, evening compiler design going on. It is the compiler design is there in the middle, right? After algo is over, right? Algo is over, right? One more subject I will start. Morning one, evening one. Morning one, evening one. Within 6 months, you can complete total syllabus. My suggestion is, if you are serious about GATE examination, join Unacademy as soon as possible. That is my suggestion. My real motto is that only. I don't want you waste time right, on YouTube. I don't want you waste time on YouTube. My real suggestion, really I want to guide you. That is the reason I came. Maybe you may think about the little bit of amount, but there is an offer also going on. 30% off. 30% off is going on. You can utilize. Use referral code ReddySir. Use referral code ReddySir. Thank you so much. See you in tomorrow's class. See you in tomorrow's class. Thank you so much. Right, good night.